Welcome to class, everyone. I'm so glad you're here today because we've got a really fascinating scientific investigation lined up for this explainer. We're going to be exploring how we interact with the world right around us, specifically how we understand hot and cold. It's something we literally experience every single day, right? But as you're about to discover, our own bodies might actually be playing some serious tricks on us.
Let's quickly look at today's lesson plan. First up, we'll ask, can we actually trust our sense of touch? Then we'll define what temperature exactly is, we'll check out clinical and laboratory thermometers, and finally, we're going to learn how to use those tools safely.
All right, Section 1. Can we trust our touch?
So to kick things off, let's look at a story about a student named Lombok. He came home from school one day feeling kind of feverish, so his sister Fiban did pretty much what most of us do. She touched his forehead. Now, have you ever wondered about this yourself? Can we actually tell if someone has a fever just by touching them? Can we really trust our own sense of touch to give us the scientific facts?
To test this out, I want you to imagine doing the classic 3 containers experiment. So, picture this. You take 3 large bowls. In the first one, you pour warm water. In the third one, ice-cold water. Now, you dip your right hand into the warm water and your left hand right into that ice-cold water, and you leave them there for a full minute. Okay then, you pull them out and plunge them both at the exact same time into the middle container, which is just filled with totally normal, room temperature, tap water.
Now, what happens next is wild. Your right hand, which was just chilling in the warm water, is going to tell your brain that this middle tap water is actually cold. But your left hand, which was practically freezing a second ago, will totally insist that the exact same tap water is warm. It's crazy, right? But this proves a super vital scientific principle for us. Human senses are completely subjective. We simply cannot rely on our sense of touch to decide if an object is hot or cold. It just doesn't work.
So since our hands can trick us so easily, we need to move on to some objective facts. Section 2, what exactly is temperature?
The absolute crucial takeaway here is that instead of just, guessing if something feels hot or cold, we have to measure its temperature. So what is it? Well, temperature is a reliable scientific measure of the hotness or coldness of a body. Basically, a hotter body has a higher temperature than a colder one. It's that simple. But to get this objective hard number, we absolutely need a specific tool, and that tool is a thermometer.
And honestly, this brilliantly illustrates exactly why guessing just isn't going to cut it in science. The famous Indian meteorologist Anna Mani, she once hit the nail on the head. She said, wrong measurements are worse than no measurements at all. Think about that. Having bad data, like guessing someone has a fever when they actually don't, or missing a real fever entirely, is literally more dangerous than having no data in the first place. We've got to have the right tool for the job.
Which brings us to our first essential tool. Section 3, the clinical thermometer.
So, a clinical thermometer is a device we use specifically for measuring human body temperatures. Now, back in the day, older thermometers used mercury, which, if you didn't know, is an extremely toxic substance. Super dangerous if the glass breaks. But today, thankfully, we mostly use digital clinical thermometers. These guys run on batteries. They use electronic heat sensors to safely figure out the temperature, and they measure everything on the Celsius scale, which we call degrees Celsius.
Okay, class, I want you all to lock this crucial number in your brains right now. 37.0 degrees Celsius. That right there is the normal temperature of a totally healthy human adult. Human body temperatures generally don't ever dip below 35 or shoot up above 42 degrees. And that is exactly why the clinical thermometer is specially designed to cover just that very specific narrow range.
But hey, what happens if we're not measuring a person? What if we're doing a science experiment? That brings us to Section 4, the laboratory thermometer. For science experiments, like testing boiling water or melting ice, we use a totally different tool, the laboratory thermometer. This is a device meant specifically for scientific purposes. More often than not, the liquid you see inside a lab thermometer is alcohol that's been dyed red. This is a neat little trick because it makes it incredibly easy for us to see the exact temperature reading as that liquid moves up and down the scale.
Now listen up, because here is an absolutely critical rule for all your future science experiments. Unlike when you're checking a human for a fever, you have to read a laboratory thermometer while it is still completely immersed in whatever liquid you're measuring. If you pull it out to look at it in the room air, bam, that red liquid column is going to start dropping immediately, and you'll end up with totally useless, bad data. Let's actually put these two side by side, because it really builds a clear picture. On one hand, clinical tools have a very narrow range, right? Custom built just for human bodies.
But laboratory tools, they need a massive range. They usually go from -10 degrees all the way up to 110 degrees Celsius, because they literally have to handle the whole shebang, from freezing solid ice to bubbling, boiling water. All right, let's wrap things up with Section 5, using thermometers safely.
Let's loop right back to the story of Lombok and his sister, Fiban, so we can see how this works in real life. Remember, Fiban thought Lombok's forehead felt warm. But she was smart. She didn't just rely on her sense of touch. Instead, she grabbed a digital clinical thermometer and followed some really important safety steps. First, she washed the tip with soap and water, being super careful to keep the digital display perfectly dry. Then she held it without touching the tip, placed it correctly, and just waited for the beep before reading it. And to her total relief, Lombok's temperature was perfectly normal. Her hand had literally just played a trick on her.
So, class, I'm going to leave you with this final thought. Next time you're feeling under the weather, or hey, next time you're running a critical science experiment, what's it going to be? Are you going to trust a simple touch that we know can be so easily fooled? Or are you going to tap into the objective power of true scientific measurement and use the exact right thermometer for the job? Thank you all so much for joining me for this explainer today. Stay curious out there and always remember, measure accurately.